Okay, we'll get started. Thank you so much. So first of all, thank you to Adcom for inviting us and providing this opportunity to talk about IP and AJA. So I'm Andy Bellamy. I'm the Technical Director for AJA in the EMEA region, so I look after Italy. And we're going to cover a couple of products which are in the IP space that we produce, and we'll go into those in a bit more detail in this presentation. So the first product we're going to talk about today is the Bridge Live 12G4. So the 12G4 is the newest and most advanced member of the Bridge family, and this was developed in close collaboration between AJA and Comprimato. So Comprimato are our partner in all things streaming. The Bridge Live 12G4 builds on the existing platform, so we already have two previous models, the Bridge Live and the Bridge Live 3G8, which was released back at NAB. So this new version of it is 12G4, and this adds 4 simultaneous 4K UHD channels. So for live event streaming, video backhaul, remote production workflows, it delivers robust real-time encode and decode and transcode and delivery, and does that all at scale as well. I'm sure these are some of the buzzwords you'll be hearing during the event over the next couple of days. But at its core, Bridge Live 12G4 is all about flexibility. So it supports a wide range of industry codecs and transport streams, which are ideal for high quality contribution, long distance fiber workflows, or production environments where image fidelity and latency are critical. And codec support. So Bridge Live 12G4 supports the widest range of codecs, transport formats, and streams. So to start with, we have H.265 and H.264, so that gives you efficient encoding across any bandwidth profile. For legacy systems, though, we do support MPEG-2 as well. We fully support NDI, SRT, MPEG-TS, RTMP, HLS, and for sending feeds to the cloud, public internet, or a traditional broadcast plan. There are support for further codecs, though. It does have support for JPEG 2000 and JPEG XS. So these are industry standard codecs for visually lossless, low latency contribution over IP. So these are very key to what this event is all about, which is all about how do we bring high quality video with the minimum amount of latency and share it over our IP network. You can use JPEG 2000 for studio to studio workflows or archive quality transport. And JPEG XS is when you need ultra low latency and high visual fidelity. So that's really useful for live playout, OB vans, and long haul fiber networks. Both JPEG 2000 and JPEG XS are available as an add-on license for the device. It's not just about video, though. Obviously, audio is a huge part of what we do here. So we support up to 16 channels of embedded SDI audio per stream, and that covers you for AAC, PCM, AC3, and MP2 codec options as well. So plenty of flexibility in terms of the audio and what audio you can bring in. On the metadata side, we don't strip out any metadata, we handle it all. So we can use closed captions if those are a part of the stream. We can add the insert markers for ads, so SCTI 35 or 104, electronic program guide, and also time code as well. So full compliance from source to screen all the way through. So you're in synchronization with what's coming through. So these are some practical examples of where Bridge Live 12G4 would work in the field. The first one we're going to look at is live event streaming. So in essence, high quality, low latency streaming. So multi-platform streaming is also part of this, remote contribution and return feeds, and this is all done over the reliable public internet. This is an example of how that might work. So at the bottom of the diagram there, we've got our program feed and cameras coming into the Bridge Live 12G4. These are then being sent over SRT or HLS or RTMP to our public internet and then onto the social media and video streaming platforms. So very simple to set up and to get connected. Backhaul is obviously also very doable with this device too. So contribution quality encoding for remote locations, bidirectional video over public or private IP, multi-channel flexibility, which is you need that out there, and cost-effective redundancy and routing as well. So this is a very straightforward example of that. We've got at the top the remote sources, so this could be an outside broadcast somewhere, and at the bottom we have the media facility. And we are taking in our cameras, and there are cameras A, B, and C coming into the Bridge Live 12G4, which we're then streaming over the internet to another Bridge Live 12G4 at the media facility. The media facility is also then able to send back the program feed back to the outside broadcast because we have enough bandwidth in the device. They're bidirectional. You can mix the two together. So remote production, very straightforward to understand, multi-channel encode and decode, SDI and IP interoperability. So I think that's a key takeaway from what we're talking about today is both worlds still exist. So being able to preserve a signal path for both worlds is really useful. Low latency, reliable transport, which is obviously a no-brainer for remote production, and centralized control and monitoring as well. So anybody that needs to see a feed can be given one by the Bridge Live 12G4 and monitored. So this is an example of 4K and HD remote production using the Bridge Live 12G4. So on the left-hand side, we've got IP sources as well. So this is a mixture. So we have here two PTZ NDI cameras coming in. We also have two 12G SDI cameras coming in as well. So the Bridge Live 12G4 is then able to take those feeds, send them over SRT into the public internet, something like H.265, which is a really good compromise over bandwidth and quality. In the middle there, we're actually sending out feed monitoring and reference video to anybody that needs it as well. So that's an easy way of connecting external agents that need to see video and have that connected to them really easily and securely. And then at the other side, on the right-hand side of the image, we have the media production facility. So all of this content is then being passed over SRT. It's then decoded by another Bridge Live 12G4, and then it can go back into the production pipeline as SDI if that's what's required. It's a very straightforward way of achieving that over public internet. So it's got a nice user interface, so you can control it locally or on the network, and it's the same UI as the other bridge models as well. So if you've used one of those or are familiar with it, it will just follow on in exactly the same way. So in setting up the device, we go from the left-hand side, we create a pipeline, then we decide on our input video, and then we decide on our output stream mapping, and that's really it. You go from left to right on the screen, set up the individual pipelines, and you're up and running. So very, very easy to configure. And let's take a look at the back of the device. So dual redundant power supplies on the left-hand side, USB ports for mouse and keyboard, and then dual 10 gig E for both I/O and also network control as well. So plenty of bandwidth for even the most demanding of situations. The 412G SDI ports, as I mentioned earlier on, this gives you multiple 4K or UHD SDI channels of input, and DisplayPort for local monitoring as well. So you're able to use a monitor and a keyboard and a mouse and actually use the thing locally if you want to. And of course a reference input as well. If there is house sync involved, we can play with that very nicely. And NDI is very straightforward. Essentially, we're able to bring in NDI sources and go out to compressed sources like 264. We're able to bring in 264 and go to NDI, or 265 and the vice versa for NDI as well. So depending on what your sources are coming from, you can have NDI sources which are outputting clean NDI streams to vision mixers and so on. You're able to set up the device accurately and able to then fit in with your NDI workflow needs. If you go to our website, there's a fair few customer stories as well, which give really good examples about how this product works in the field. Those are well worth taking a look at. So the Bridge Live 12G4 is just under $18,000 and is coming very soon, and that will ship with a full 3-year warranty. So that's just a quick recap. So the Bridge Live 12G4, as we said, 4 12G SDI inputs for multi-stream 4K UHD up to 60p. With the dual 10 gig Ethernet ports at the back for transport and control. Broad codec support, as we said, NDI, JPEG XS, JPEG 2000, H.265, 264, and 262. Container support, I think, is pretty much unmatched out there. SRT, HLS, RTP, UDP, RTMPS, and MPEG-TS as well. And just one RU, so very compact chassis for that device. So that's the latest member of the BridgeLive 12G 4 range. And if you want to find out more, you can go to aj.com to see more workflow examples for that particular device. So the second device we're going to look at today is the IP25R. So moving away from the IP world of NDI and 265 and 264 encoding, this is really looking at how could we produce a device which sits between the worlds of 2110 and SDI as well. So in essence, it is a very simple device. We have IP video and audio coming in over fiber channel on the left-hand side there. Those are going into the two 25 gig fiber cages on the front of the device. And put simply, we can then turn that IP video into baseband video. And we have 4 12G SDI outputs and 2 HDMI 2.0 outputs to choose from. So in essence, it receives and decodes ST2110 to both SDI and HDMI simultaneously. It will support up to 4K 60p 10-bit 422. So really, the prime examples of the higher frame rate for this device would be anybody working in sports. This is going to be perfectly compliant with your high frame rate workflow. We offer in-band and out-of-band control, and I'll tell you a bit more about that as we move through the slides, and full HDR support, and also an awful lot more. So in terms of format support, it's 4K at the very highest, all the way down to 720p for HD at the bottom and everything in between, and it's 422 10-bit up to 4K 60p as well. So let's take a look at the device in a bit more detail. So this is the front of the device. So as I mentioned before, we have the dual 25 gig SFP28 cages. We have the 1 gig Ethernet for out-of-band control. So in-band control takes place over the 25 gig SFP cages. And that will give you NMOS 04 and 05, Ember Plus, for example. And then the 1 gig Ethernet port is for out-of-band control. And we provide you with a number of different methods of controlling the device using out-of-band as well. And we'll see why that's a good idea shortly. USB-C is just for initial network config only. You can set up the device, set everything up that you want to do with it, all locally if necessary. And the back is very simple. It's 2 HDMI 2.0 outputs and then 4 12G SDI outputs as well. And these are always on. So it's a true cross point in the device. So any video coming in, and we could have up to 4 video essences coming in to the device itself, we can set them wherever we want them to go on the output device. So that's any video, any audio, or ancillary data. Obviously, they're all coming in separate. We group them together and then allow you to pass them out of the SDI or HDMI routing on the back of the device. So network connectivity, as I said, you've got the in-band control happening with the dual SFP cages at the front there. So that's the video, the audio, metadata, PTP, and in-band control takes place there. And then all out-of-band control takes place over the 1 gig Ethernet port. So just standard off-the-shelf SFP modules. Doesn't have to be anything in particular to work with this device. Well, obviously, it will work with 10 gig SFPs as well, but there'll be a hit in terms of the highest frame rate you can do with that. So with that network connectivity, we get ST2022.7 redundancy. Part of the 2110 system is the redundancy, and this will provide it for you. There are 4 RX channels that can come into the device, and that can be up to 16 channels of audio per input as well. So plenty of flexibility for input in terms of audio and video. So there's a built-in web browser UI, we'll see that in a moment. NMOS ISO4 and ISO5, Ember Plus, and then the AGA REST API as well. So multiple ways to control the device in operation. So you can configure it using any browser on any platform. It just works with a fixed IP address or a dynamic IP address. You just need to type that into the browser and then you can access all the functions of the device. And that's what the UI looks like. So at a glance, we can see we have video preview. So one of the tough things about working with IP video is not always being able to have a preview of it. And in the 2110 world, obviously we're splitting up video, audio, and ancillary data as 3 separate essences. The IP25R allows you to actually see a thumbnail. So even though we can read descriptions of video in the general IP workflow, and we know roughly what it is, or what it's described as being, nothing really beats a thumbnail in terms of being able to see at a glance what's happening, and that's a live video preview as well. So as you go through the separate streams that are coming into the device, you are able to monitor them and make accurate decisions quickly by seeing the actual video itself. And this is a look at the more detailed technical screen. So this is the readout for each of those essences, which is very useful and very informative, but I think the thumbnail just does a better job of, at a glance, being able to describe what's happening. So HDR is fully supported, so hybrid log gamma and PQ workflows with SDP to VPID and info frame translation. There's HDR metadata override for precision control. And we preserve both BT709 and BT2020 colorimetry with override, so you can ensure accurate monitoring across multiple formats. Again, one of the things you might be hearing a lot about over the next couple of days is PTP clocks and timing. So the IP25R is fully compliant with PTP v2. So this ensures perfect alignment with your SD2110 system clock. The precise timing means you get extremely smooth switching, extremely accurate video and audio sync, and stable multi-device operations. So these clocks are fantastic, and the IP25 just follows the lead of the clock without fail. So the device itself also offers you standard test patterns. So if you're setting up in a 2110 network and you want to drive monitors but you haven't got any video yet, you can do that using test patterns that enables you to get working before everyone else is set up fully. It's extremely compact, so it's a very small device. It's front to back airflow with it, which means we can put 6 units in our DRM2 Plus frame. So this allows you to have redundant power supply for all 6 units, or you can put 3 units on a single 1RU rack shelf as well, side by side. So plenty of options to put these in a rack where needed. So who is it for? Anybody basically working in a 2110 environment that needs to have baseband video, this is who it's for. So if you're talking about a production facility with 2110, they still need to drive mission critical monitoring. Unless you have a 2110 compliant monitor, you're going to need a device like this. So this means you can run multiple monitors in suite with baseband infrastructure, all from a 2110 system. Same deal with a broadcast truck in terms of what they might be working with there for multi-viewers and so on, and live events as well that are also leveraging an IP video network as well. There's no latency in the device, so it's very straightforward to monitor in the field. So this is an example of a 2110 workflow we've got here. So the left-hand side, we have our redundant media network. We've got 4 sources coming in which are high definition. And those are all 1080p 60. And we're just going to simply go to SDI and HDMI monitoring. So the device takes from the network the 4 HD 2110 streams. And then on the right-hand side, you can see there, we're driving a router at the top, so that can take those signals wherever they need to go, and then 2 HDMI monitors directly as well. So that's all simultaneously from the same unit. And this is just an example of a UHD version of the same thing. So just a couple of UHD sources coming into the device, and then it's just doing a straightforward conversion to HDMI again, and also passing the 12G sources into the Kumo router for further distribution. And this is more, a confidence monitoring workflow. This is more likely to be a high-end application of the device, so this is really using it with an OB truck infrastructure. So SIMPTE 2110 camera and switcher setup here. We've got the 4 2110 cameras coming into our redundant media network. We have a 2110 switcher as well. We have a device, a PC for in-band and out-of-band management as well. And those feeds are then going into the IP25R. The IP25R can then drive everything you see there simultaneously. So it's driving 3 SDI monitors, 2 HDMI monitors, and then the 4th 12G SDI is driving a color box, which is our color workflow device for inline color transformation. So this is more likely what you might see if you're using an OB infrastructure for a live event. And as I mentioned before, multi-viewing is one of the prime uses for 2110 in the field. And we're no different. We just take in the multi-viewer engine. It could be a quad, it could be 16. And we take those into the IP25R and then allow you the functionality to either route them via a Kumo, so it goes straight to an SDI router, or to drive directly HDMI monitors, as we can see there in the bottom corner. So that's definitely a powerful example of how the real world we need to still use baseband for video, and this device lets you do that. It's part of a range of other devices that we do as well. So you may be familiar with the Kona IP25. We've been shipping that now for roughly a year, and that is our 4x RX and TX editing card. So basically a video I/O card for all things 2110 video editing. Then we have the IP-R and IPT converters as well. So these are just small throwdowns, 10 gig, nice and easy, and again, achieve the same kind of thing as the IP25R, just being able to turn that 2110 into a baseband video signal really easily. So that's it. So that's the IP25R. It's actually shipping next week. So we had an update yesterday from the factory, so it's ready to go out. It's just under $4,000 and carries a standard 5-year warranty. And if you want to know any more about these devices, there is, just a quick recap. So the IP25R, as we said before, 4 12G SDI outputs, 2 HDMI 2.0 outputs, control both in-band and out-of-band, and a web browser UI too. Compliant up to 4K for DCI, and also fully compliant for HDR all the way through, and pretty much the best format support in the industry as well in terms of multi-channel, UHD, and HD as well. If you want to find out more about that, we're over at the AJ section outside. I'm happy to chat more about this, or if you want to learn more on the website, the IP25R is on the AJ.com website, and you're able to go through there and find out there are more workflow examples. And when it ships from next week, also the manuals will be available for the device as well. So if you want to find out more, please go over there. Thank you very much for your time today. If you want to get in touch with me, that's my email address. I am your representative in the region, so happy to help with anything that we can do. That's it. Thank you so much. Thank you.